Hi, and welcome to this tutorial which will cover the more advanced metering features of Pro-L. Pro-L's meters display both peak levels and RMS levels on the same scale. The brighter RMS levels are averaged over time in order to reflect the apparent loudness of the material, while the darker peak levels show instantaneous sample values and therefore how much headroom you have left. However, individual sample levels don't tell the whole story when it comes to signal peaks. When the digital signal is converted to analog, the resulting continuous waveform will often peak higher than any of the original samples. If these inter-sample peaks are too extreme, they can distort when played on consumer playback devices, or when converted to lossy formats such as MP3. It's therefore conventional to leave a bit of headroom by setting the output level just below unity. Minus 0.1 dB is a common choice, although many people use more conservative settings of minus 0.3 or minus 0.4 dB. However, inter-sample peak levels depend very much on the nature of the program material and the amount and type of limiting applied, so the only way to know for sure if they're a problem is to enable the ISP option for the meters. This switches in 4 times oversampling for just the metering, so we're now literally measuring the signal levels in between each sample. And you may be surprised at how high these ISPs can sometimes be. We can tweak Pro-L's settings to reduce ISPs if needed. The most obvious way is to reduce the gain setting and avoid applying more limiting than absolutely necessary. But the type of limiting applied is also a factor. I'm using the clipping preset at the moment, which uses the minimum look-ahead setting of 0 milliseconds. The look-ahead setting controls how far in advance of each transient the limiter will start to act. Longer settings make the gain reduction smoother and safer, and are less likely to cause high ISP readings. But longer settings will also soften the attack of your drums a little, so you may want to experiment with settings inside or just outside the red zone to find a good compromise. Also notice that this preset uses a very slow attack time setting, which may not be what you expect from a clipping preset. In actual fact, this setting means the main limiting stage is reacting too slowly to catch the peaks at all, so the work is all being done by the very fast and aggressive transients stage. If I switch the meter scale to the minus 16 dB setting, we can clearly see the almost instant release after each peak. And because the main limiter stage isn't doing anything, dialing in a longer release time makes no real difference. Now notice what happens if I turn the attack time down. When it gets short enough for the main limiter stage to start catching the peaks, we see the longer release time I dialed in start to take effect as well. And I can now adjust the release time to create a range of gluing and pumping effects. Our original clipping settings had stereo linking turned all the way down for both limiting stages, however. So the gain reduction is independent for both channels, and this setting might start to introduce shifts in the stereo image. Turning the release linking up will reduce this effect if it's a problem. But of course you may like it, in which case you might want to try turning the transient linking all the way up instead. This will keep short peaks centered, while allowing the body of the sound to wander about in interesting ways. This type of gentler limiting setting is much less likely to cause high ISP readings than the clipping settings I started with. But ISPs are still possible, in which case the best solution might be to enable one of the oversampling modes at the bottom. A combination of 4 times oversampling, plus a minimum look ahead of 0.1 milliseconds, will restrict ISPs to about 0.1 dB over the threshold, even with very fast limiter settings. And as a bonus, this will also significantly reduce the aliasing distortion that this type of very fast setting can produce. Okay, now let's take a look at the K-scale metering modes available from the metering menu. These were devised by mastering engineer Bob Katz in response to the loudness war which has been running ever since the introduction of the compact disc format. Each subsequent release has attempted to be louder than all its predecessors, and in recent years it has become common to see releases so heavily compressed and limited that they appear as solid blocks when viewed in an audio editor. It's important to remember, however, that the listener's response to this is simply to turn their own volume down, and the loudness war is therefore ultimately self-defeating. Of course, with no standards in place, it can be difficult to judge how loud to make your own mixes. So the K system proposes 3 different standards, each designed for different types of program material. Let's pick K20 to start with. And the first thing to notice is that, unlike most digital meters, 0 is no longer at the top of the scale. Instead, we have a nominal unity gain at -20 dBFS, with a 4 dB yellow zone above it, and a red zone above that. RMS levels should be kept within the yellow region for loud passages, and should only enter the red zone for occasional very loud fortissimo sections. This leaves plenty of headroom to accommodate peak levels, so the K20 scale is useful when you need to retain a very wide dynamic range, such as for a symphony orchestra, or a film soundtrack intended for cinema release. K20 is also a useful scale when dealing with material with a high peak to average ratio, otherwise known as a high crest factor, for example an uncompressed recording of an acoustic drum kit. K20 is therefore a useful scale to use while mixing any type of material, as working with plenty of headroom like this allows you to concentrate on the sound and frees you from having to worry about clip lights on your mix bus. Let's switch to K14. This works in the same way, except Unity is now set at -14 dBFS, and the red zone is much smaller than it was. I can therefore raise my audio from K20 levels to K14 levels by applying 6 dB of boost from Pro L. With a typical pop or rock mix, this will usually only require subtle limiting of just the loudest peaks. K14 is loud enough to be easy to listen to on budget stereo equipment or on MP3 player earbuds, but still has enough dynamic range to sound punchy and three-dimensional, and avoid fatiguing the listener. The final K12 setting is the loudest of the 3 in absolute terms, with only 12 dB of headroom above our Unity reference level, and this meter is designed for material intended for broadcast. The extra 2 dB of gain required to reach K12 levels will translate to 2 dB of extra gain reduction for the peaks, so you may need to take a little more care over your limiting settings. Strictly speaking, your monitor gain should be calibrated so that unity on the meter equates to 83 dBc in the control room. And when you switch from a K20 scale to a K14 scale, you should also drop your monitor gain by 6 dB. But don't worry too much if you have no way to calibrate this properly. Even just going by the meters will give your output much greater consistency and will take the guesswork out of choosing your target levels. That's all I've got time for in this video, but you can get more information by launching the detailed user manual via the help menu. Thanks for watching.